Hello everybody, this is my group 1 presentation. I was gonna do it kind of like a voiceover because I made sort of like a keynote or a PowerPoint presentation, but it decided it didn't want to work for me that way. So I'm kind of going an old-fashioned way and using my phone to video me just going through the PowerPoint presentation this way. So here it is. And I kind of just decided to blow up the pictures that he put on the presentation page with the prompts just to see them a little bit bigger. And so I'm going to go through the first prompt first, which kind of had a few different questions in it. The first one is kind of talking about the different principles in which alpha helices are held together. And so first I kind of wanted to just briefly go over what an alpha helice was. And so I kind of found obviously that alpha helices are just chains of amino acids that fold into spirals, and so the spirals are the alpha helices. And then the alpha helices are actually held together with hydrogen bonding. And what I found online as well as in the book that with these bonds is that opposites attract. And then also with alpha helices, they are secondary structures because this is the way in which these amino acids are going to interact with each other to form their regular shapes, which are usually the alpha helices or the beta pleated sheets. The next part of the prompt talked about what could we replace the leucine with in that structure to maintain the hydrophobic core. And so to maintain the hydrophobic core, I kind of thought we would want to replace it with an amino acid that is going to be similar in size as well as in kind of the classification. And so leucine is an amino acid that is hydrophobic, that has the hydrocarbon side chain, and it's also in the category with a larger aliphatic side chain. And so the other amino acid that falls into that same category is isoleucine. And isoleucine also has the same number of carbon atoms in its side chain. So I think by switching out those two amino acids, there really shouldn't be a change in the function and being able to maintain the hydrophobic core, since both amino acids should be able to exert the same hydrophobic interactions based on the similar side chains that they both have. The last part of that first prompt kind of talks about or asks us to pick which amino acid we could put in instead of leucine to destabilize the hydrophobic core. So we would want to look for an amino acid that is going to be more polar and is going to have a positively charged side chain. And so one amino acid that's going to fall into that category would be arginine or a lysine amino acid. So we would want to look at the structures of both the leucine and then I would say probably the arginine amino acid, because the arginine amino acid has the positively charged side chain, and then it also has the it's got 3 nitrogen atoms in the side chain, and those are all going to be polar, and so those would be able to form a hydrogen bond with any other polar residue basically anywhere near it. And then the arginine amino acid also just has a much bigger side chain than the leucine amino acid does. And then so replacing the leucine with arginine is probably going to be most likely the best way to destabilize the hydrophobic core. I guess my main point being here is we wanted an amino acid that was going to be hydrophilic, that would be able to break the hydrophobic interactions that were going on there. And then the last prompt he wanted us to talk about was what we could replace the lysine and the glutamate ions with, kind of in this picture, so in those top two. And so I guess my thoughts for this were to replace them the glutamate for sure with aspartate, and then to replace the lysine either with arginine or histidine. And with this, I kind of just looked at the side chains again. So aspartate is in the same category as glutamate, in that they're both negatively charged amino acids with acidic side chains that are negatively charged as well. And then both arginine and histidine are both in the same category as lysine, in that they are both positively charged amino acids that are hydrophilic. Arginine, however, is more similar to lysine in that it has a long side chain that terminates with groups that are positive at a neutral pH, while histidine is different in that it contains a midazoline group, an aromatic ring that can be positive. So I would say, I guess, aspartate and arginine are maybe a little bit better pair to replace those two, but histidine could also be an option. So yeah, that's my answer to all those questions.